Okay, so I'm going to run through the review. Get some board space. I hope I can finish them all by the time we are through. For number one, I want to share the screen. I want to actually get this so I can, let's see, week of one. I'm going to open this up. And so maybe I don't necessarily need to write everything down on the board. So for the first one, it's going to load. This thing has degree 3. Okay, the degree is 3. It's the highest power of the polynomial. The leading coefficient is -8. Don't forget the negative. Okay, don't forget the negative. All right. Okay, the second one, simplify. What I'm going to do is I'm going to, I guess I'm going to write this out. So I get 4 minus 8x times 4x squared plus x minus 7 minus x minus 9x to the third. Okay, so what I have to do is I got to multiply each of these through. So I'm going to multiply that, and then that. Okay, when I do that, I get 4 times, so I get 16x squared. That's the first one. Okay, plus 4x minus 28, minus 8x, negative 32x to the third, minus 8x squared, plus 56x. Okay, that's that all multiplied. And then I'm going to carry the -1 through there, so negative x plus 9x cubed. Okay, now I'm going to combine like terms. The x squared terms I'm going to circle in red. That's it. The x terms I'm going to circle in blue. The x cubed terms I'm going to circle in green. And then we'll leave the constant term alone. So add these. Negative 32 plus 9 gives me negative 23. So negative 23 x cubed. Add the reds. 16 minus 8 is 8. Okay. Blues. Positive 4. Positive 4, positive 56 is 60, minus 1 is 59. And I realize I made an error on my answer sheet. And then minus 28. Did I made an error on my answer sheet or I made an error here? They don't match. All right. Anybody find a mistake that I made here? Let's see, how did I get 4x? 4, copied or down right? And where did I make my mistake? Oh, negative 56. Negative 56x? No, that should have been positive 56. I made an error on my answer sheet. Yeah, I made an error on my answer sheet. Okay, so that's the answer for that. I'll have to fix that later. Okay, next one. Stop me at any time if you have a question. Otherwise, I'm just going to keep on rolling. 75 a squared minus 108. Okay, I'm going to factor a 3 out of this, and I can get 3 times 25a squared minus 36. And I notice that's the difference of 2 perfect squares. So I get 3 times 5a plus 6, 5a minus 6. There's my answer for that. Next one, 6x squared minus 37xy plus 45y squared. Okay, this is where you have to do the x method or the box method or whatever method you do. Okay, what I do, the proper combination that I found Those 2 and 3 going with -5 and -9. You just got to find, find the factors that work for you. And that's 2x minus 9y and 3x minus 5y is your answers. 2 goes with the -5 and 3 goes with the -9. There's your answer for that. Okay. See if I can squeeze this next one in here. -x to the 4th. Change markers with that one. Itself. Negative x to the 4th minus 12x squared minus 32. First thing I'm going to do is pull a negative out of there. So I get x to the 4th plus 12x squared plus 32. And then, oops, that's squared. And then factors of 32 that add to 12 are 8 and 4. And so I get negative. So for this, I get negative x squared plus 4 and x squared plus 8. And that's all the farther we can take that. We can't go any further. Okay? Okay? All right. Questions so far? Okay, next. What's next? Solve each of these equations. Give exact answers and find all solutions. All right, so the first one is x to the 3rd plus 4x squared equals 38x. 38x. All right, pull the negative 38x out, or bring it to the other side, and we get x to the 3rd plus 4x squared minus 38x equals 0. Okay, I'm going to pull an x out of there, so I get x times x squared plus 4x minus 38 equals 0. I know x is equal to 0 is one of the solutions. Okay, and then I have factors of negative 38 that add to positive 4. Unfortunately, there aren't any whole numbers that do that, so I have to use the quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. B is 4, so it's negative 4 plus or minus 16 minus 4 times 1 times negative 38. So that's going to turn that into a positive. 4 times 38 over 2a. 2 times 1, or just 2. Okay. To make a long story short, geez, I'm making mistake after mistake on this answer sheet. These answers are incorrect. Boy, because I made an error on the sign here on the answer sheet. So I'm going to do this myself. 4 times 38 plus 16. And I'm going to do that. 4 times 38 plus 16 is 168. So this is plus or minus the square root of 168 over 2. The square root of 168, what goes into that? Divide that by 4. I know 4 goes in that, 42. So this is going to be negative 4 plus or minus the square root of 4 times the square root of 42 all over 2. This is negative 4 over 2 is negative 2. Plus or minus the square root of 4 is 2. That's going to cancel out that 2. So I get square root of 42. And that's those are my other 2 roots. And yeah, I'm disappointed at myself for making errors in the answer sheet. I hate when I give you guys wrong information. But I think I did that correctly. If I made an error here, let me know. Question?
So that one, that answer from using the quadratic formula, that's 2 answers?
Yes, because of the plus and the minus. If I wrote it out, it would be negative 2 plus root 42, and that's a root, and then negative 2 minus 42. that is another root. Okay. All right. Anytime you take the square root of something, there's both a positive and a negative answer. That's why I go plus or minus. And that gives me three roots. 1, 2, 3. Okay. All right. Next. Get a different marker. This one's probably getting tired. X cubed plus 9x squared equals 4x squared minus x minus 5. Okay. All right, now I got to bring everything over. So subtract the x cubed is okay. Subtract 4x squared, you get positive 5x squared. Bring the x over, plus x. Bring the 5 over, plus 5 equals 0. Okay. I'm going to pull an x squared out of those two. Whenever you have four things, look to factor by grouping. Okay? Look to factor by grouping. Come on. All right? Whenever you have four. So I'm going to look to factor. I'm going to pull an x squared out of that. And I'm looking at x plus 5 there. And then plus 1 times x plus 5 equals 0. So then I can factor out the x plus 5, x squared plus 1 equals 0. And then x plus 5 is equal to 0, or x squared plus 1 is equal to 0. Subtract the 5 to get x is equal to negative 5. Subtract the 1 to get x squared is equal to negative 1. Root that, and we get plus or minus the square root of negative 1, or I. And those are your three roots there. Okay. Then, let's bring the computer over here so I can use a little bit more on my board here. There's my physics stuff. And what do we have? X to the 5th equals 5x minus 4x cubed. Okay, bringing everything over to the same side. Add 4x cubed to both sides. Subtract 5x from both sides. Let me get that. And then I get pull out an x, and I get x times x to the 4th plus 4x squared minus 5. 0. That gives me x is equal to 0. That's one of my solutions. And then, let's see, can I factor this? Factors of negative 5 that add to a positive 4. Yes, I can get x squared plus 5 and x squared minus 1 equals 0. That factors. So I can set each of these equal to 0. So x squared plus 5 equals 0. And x squared minus 1 equals 0. Subtract 5 to get x squared is equal to negative 5, square root it, and x is equal to plus or minus the square root of negative 5, which is the square root of negative 1 times the square root of 5. Square root of negative 1 is I. So this is plus or minus I root 5. And then over here, adding 1 to both sides, I get x squared is equal to 1. Square root it, and I get x is equal to plus or minus 1. Which you would also get if you factored, notice that this is a difference of two perfect squares. So you could factor that additionally to be x plus 1 and x minus 1. And then set each of those equal to 0, which would lead you back to this answer as well. Okay, so this needs a total of 5 roots. I have 1, 2, 3, 4, 5. All right. All right. Next. Bring this over here. Got to do a long division. 2x plus 2 into Oh, they gave it to me in wacky form. I gotta put that in descending order. 4x cubed minus 8x squared. They didn't give me an x term, so 0x plus 1. Put it in descending order. Okay? All right, what do I have to multiply 2x by to get 4x cubed? 2x squared, right? 2 times 2, x again. So then 4x cubed plus 4x squared. Okay? Change the signs and add. -8, -4, -12. Bring down the 0x. Okay, what do I have to multiply 2x by to get -12x squared? That's -6x. So -12x squared minus 12x. Change the signs and add. And I get 12x plus 1. And then plus 6. 12x plus 12. Change the signs and add. And I get -11. That's my remainder. So 2x squared minus 6x plus 6 minus 11 over 2x plus 2. And there's our answer to that. Okay. Next, is x plus 7 a factor of blah, blah, blah? Show any work that leads you to your conclusion. What I'm going to do is I'm going to use synthetic substitution to see if it is. So I'm going to take the coefficients of x to the 5th. X to the 5th is 1. 4x to the 4th, positive 4. Negative 21x cubed, negative 21. Plus 2x. Oh, they didn't give me an x squared term, so I got to put a 0 in for that. 2 and 14. And if x plus 7 is a factor of that, then if I put -7 here, go through my synthetic substitution, it's going to end up with 0. And the nice part about this is I don't have to take -7 to the 5th power, -7 to the 4th power. I don't do any of that. I just focus on coefficients. That's what makes synthetic substitution so nice. Bring the 1 down. -7 times 1, add. Multiply. Add. Multiply. Add. Multiply. Add. Multiply. Add. 0. So the answer is yes, it is a factor. Okay? Whoever invented such synthetic substitution did us a big favor. Saved a ton of work. Okay, again, I'm just going to keep rolling along here. Stop me at any time if you have a question, and I'll be happy to stop. Next one. Use the graph of the function to determine at least one zero. All right, I'm going to share the screen again. Wrong mouse. Share the screen momentarily and scroll down to this one here. So I need to determine at least one zero. So looking at the function, I get a 0 right there at x equals -3. So I know, and then find the exact values of all the other zeros using the factor theorem. Okay, so since -3 is a factor, I know that if I do the same business that I just did earlier, I can get another equation that I may be able to factor. So using the coefficients of the given function, 7, 20, positive 20, negative 24, negative 60, and positive 9. And I've got all the factors of all the degrees covered. And I know that x equals -3 is a 0. So that's one of my answers, actually. X equals -3. I put that out in the margin. Okay, I got that out in the margin. Got that covered. So I'm going to put -3 in here. Bring the 7 down. Multiply, add. Okay? Multiply, add. Multiply, add. Multiply, add. And it works out. so that I know that x equals -3 is a factor. And that gives me an equation of 1 less degree. So 7x cubed plus 1x squared minus 21x plus 3. And I'm looking to get some zeros out of this. So I get a factor. Once again, I have 4 terms. So I'm looking to factor by grouping. Okay, I'm going to pull an x squared out of each of these. And I get 7x plus 1. And then happily, if I pull a 3 out of here, I also get 7x plus 1. Wait a second. What did I do? Minus 3 times 7x minus 1. Sorry. 7x minus 1 equals 0. Okay. Pull the 7x plus 1 out. And then now 7x plus 1 is equal to 0, or x squared minus 3 is equal to 0. Subtract the 1, divide the 7, and you get x is equal to -1/7. There. Take the 3 over and square root it. And those are your answers there. Okay? And along with my x is equal to -3, earlier, that gives me 4 roots. 1, 2, 3, 4, which I needed because the original function was degree 4. Okay. All right. How am I doing for time? I think I'm doing okay for time. List all the zeros of f of x equals x cubed minus 1. Given that f of 1 is equal to 0. So f of 1 is equal to 0. Once again, that leads me to synthetic substitution. Okay? So x cubed, 1, 0x squared, 0x, -1. F of 1 is equal to 0. So I should get 0 out of this. So bring the 1 down, multiply, and multiply, and multiply, and. So yes, indeed. Yes, indeed. Okay. And then what I'm left with is x squared plus x plus 1 is equal to 0, which sadly is not factorable by any method other than the quadratic formula. So I got to do that again. So x is equal to -b plus or minus the square root of b squared minus 4ac, which is that, all over 2a. Okay, well, at least the arithmetic isn't too bad. I get -1 plus or minus the square root of -3 all over 2. The square root of -3 is I root 3. So it's going to be -1 plus or minus I root 3 over 2, which actually I'll accept that. Or you can put that as -1/2 plus or minus I over root 2. Sorry, not root 2. I over 2 root 3. Or if you want to write -1/2 plus I root 3 over 2, -1/2 minus I root 3 over 2. Those are all solutions, along with x equals 1. Okay. Okay. Now, the next one, I actually made a mistake on the answer sheet that I knew about earlier. I knew about this one yesterday. Find the other zero. If 7i minus 6 is a 0, list one other 0. Usually they write this with the real part first, but they threw us a curveball and they wrote it like that. The other 0 is always the opposite of the imaginary term. So the correct answer to this is -7i minus 6. On the answer sheet, I actually changed the signs of both mistakenly. So this is the real correct answer. For number 14, they wrote it in conventional form. The other 0 would be root 17 plus 4i. Okay. All right. Number 15 is one similar to the daily 2. Factor the function, sketch a possible graph. Factor the function and sketch a possible graph. So the function, what's function? So f of x, f of x equals negative, x to the 4th, minus 4x to the 3rd, plus 16x squared, plus 64x. Okay, we got to factor this in. Well, I'm going to pull a negative x out. Is that what I did? Probably. Yeah, I pulled a negative x out. And I get x to the 3rd plus 4x squared minus 16x minus 64. Okay. And then I have 4 things in here, so I'm going to look to factor by grouping. The first 2 has a common x squared. So I'm going to pull out an x squared. I'll be left with x plus 4. Looking to get an x plus 4 out of here, I can do that if I subtract 16 or minus 16, x plus 4. That leaves me there. Then I can get negative x. I can factor out an x plus 4, and that leaves me with x squared minus 16, which is the difference of 2 perfect squares. So I can get x times x plus 4 times x plus 4 and x minus 4. And then I can combine those to get x times x plus 4 quantity squared times a quantity x minus 4. And that is the function in factored form. Okay, so sketch the graph. All right, I have zeros. Oh, did I forget a negative sign? Yeah, I forgot a negative sign. Sorry, I forgot to carry the negative sign through. The zeros are x equals 0, negative 4, and positive 4. So I'll sketch this graph. I'm going to have 0 there, there, and there. Okay, now I look at the end behavior. It's a quartic, so I knew that it's going to go either up on each end or down on each end. And because the leading coefficient is negative, that means it's going down at each end. So I know that it's going to do this. Okay, now I look at what it's going to do at the zeros, the multiplicity. It's going to be tangent at negative 4. It's going to be tangent at negative 4. It's going to go through x because it has a multiplicity of 1, and it's going to go through 4 because it has a multiplicity of 1. So that means it's going to do this. Okay. Since it's a quartic, it can have at most 3 turning points. So I'm not going to put any more turning points in there like that. That would be too many. I'm just going to leave it like this. When in doubt, don't put any more turning points in. Okay? It can have fewer, but it can't have more. It cannot have as many as 4. It can have as many as 3, but not 4. 1, 2, 3 turning points. There's your answer to that. Okay. Oh, I'm doing real good for time. Number 18. Okay, now I'm going to share the screen and give them the graph. Okay, so like this. Now we're down to this one. Okay, local minimums. Local minimums are there and there. I estimated this one to be negative 2.3, and this one to be negative 1.2. Obviously, there's some leeway in there. If you said negative 2.2 there, I'm not going to mark it wrong. But should be certainly a little bit more than 2. This should be a little bit more than 1, negative, right? Between negative 1 and negative 2-ish. Okay, local maxes are right there, 0, and they're 1. That's a little more defined. The minimum degree, how many turning points are there? Okay, 1, 2, 3, 4. If there are 4 turning points, that means the minimum degree is 5. It's always one more. Okay, now, sign of the leading coefficient. I take a look at the ends. Okay, I'm going to stop sharing for a minute. Now, you have to know the shapes of functions in general. All right, if you have, for example, the cubic function looks like this. Any function of odd degree is going to have this general, is going to have this end behavior. It's going to go down to negative infinity as x goes negative. As x goes positive, it's going to go to positive infinity. That's good for all odd degree functions. All even degree functions, the smallest of which is a parabola, are going to go up. Or shall I say, it's going to go the same way, whether it's going to positive, whether it's x is going positive or x is going negative. Either it's both going to go up or both going to go down. If it goes down, that means the leading edge is negative, or the leading coefficient is negative. If it goes up, the leading coefficient is positive. For an odd degree function, if it goes down as x goes negative and up as x goes positive, the leading coefficient is positive. If it goes the other way, like that, then the leading coefficient is negative. That's what you have to remember about this stuff. Okay? All right. Now, looking at my function here, I can see that it's the opposite of a negative degree function. Remember, the minimum degree is 5. And so if the leading coefficient were positive, it would be going down over here and up over here, but it's going opposite to that. That tells us that the leading coefficient is negative. The leading coefficient is negative. Okay? All right, so what do we have so far? No, what do we want now? Now we want a possible function for the graph, leave it in factored forms. All right, now, here's what I do. I look at the zeros. I have a 0 here at, let's see here, 1, 2, 3, 4, negative 5. So I have a zeros at negative 5, 0, 1, 2, 3, 4, and 6. So the zeros are negative 5, 0, 4, and 6. Okay. What that tells me, stop sharing for a minute. So what that tells me is, well, x equals 0, so I'm going to have an x out front. Negative 5, that's that one. Positive 4, and positive 6. Okay? I'll put the leading coefficient as negative out there so I don't forget it. And then finally, I look at multiplicity. Now, if I look at this, degree 1, degree 1, degree 1, degree 1 has only degree 4. I need 5. But if you look at the graph, look at the multiplicity of the zeros. Here it goes through odd degree, goes through, tangent. The one at x equals 0 is tangent. That tells us that it has even multiplicity. And so what that means is I'm going to put an x squared here. Okay. And that's my answer. So find your zeros, okay, and behavior, all right, and multiplicity. Okay, questions? All right, for the last one, I'm going to actually use a PowerPoint. I don't know if I can minimize this while I'm recording. I don't think I can. That's a problem. That's a problem. Maybe I can minimize this and it'll still be there. Oh, golly. Oh, I think I had it here. No, oh, shoot. Oh, wait a second. Yeah, actually, I think I did. Hold on. What I did was I did this by, yeah, I did. Okay. So I'm going to screen share. And sorry for messing around there, but I forgot the way I did this. And then I'm going to use this grid and this to do this. And I'm going to slideshow from present slide. Current slide. And then I'm going to draw a pen, or I'm going to pull a pen. Okay, now you're going to have to look at this. It says f of -2. Look at the criteria. It says f of -2 is equal to -4. So -2, -4, and that's a point. That's a point in the graph. It says x minus 5 is a factor of f of x. If it is a factor of f of x, that means that x equals 5 is a 0. 1, 2, 3, 4. X equals 5 is a 0. Okay? All right? Has a multiplicity of 7. What that means is the graph goes through it there. C, the leading coefficient is positive. That means that it goes up. It goes up. The leading coefficient is positive. Okay? And, oh, actually, I don't quite know that yet. It ends up going up, but I'll get back to that later. It says x squared is a factor of f of x. If x squared is a factor, that means x equals 0 is a 0, and it's also tangent there. And then finally, it says f of x is even. Okay, f of x is even. Remember what even is? It means it mirrors on the y-axis. It mirrors across the y-axis. That means that not only is x equals 5 a 0, but x equals -5 is a 0 also. And that f of -2 is equal to -4, and f of 2 is equal to -4. That's because it's even. And because it's even, I also know that it's an even degree function, because if it goes up over here, it has to go up over there. It can't go down over there, or it would not be an even function. So I know that it goes up on both ends. Why? Because f is even. All right, now I look at the multiplicity. So now a possible answer, I'm going to write this out. So f of x, this is going to be remarkable if I actually have good handwriting using a mouse. But I know that x is the leading coefficient is positive, so I know that's an x. And x squared is a factor, so I know that's x squared. Then this 0, x plus 5, x plus 5, and that has a multiplicity of 7, okay? And then this also, another one is x minus 5, right? Okay, now, what is, oh gosh, I cannot, oh, sorry. I have somebody waiting in the waiting room, and I cannot get out of here without, well, yes, I can. Okay, hold on just a minute. How do I get out of here? Yes, I want to keep my annotations. And then I have to do this. All right, and then I'm going to get right back in. Okay, then get my pen back. Okay, sorry, somebody got kicked out and had to get back in. So here's my function now, x squared, x plus 5 to the 7th, x minus 5. Notice, add up the degree, 2 plus 7 plus 1. That's 10. That's okay. That's all right. All right. And so this is, this satisfies all of the criteria. Now, if I drew this, okay, now remember, over here, it has odd multiplicities at both of these zeros. So it's going to go through. So it's going to go through. Okay. I'm going to go like this. I got to have a tangent here. So tangent. And I have to mirror everything that I drew to the left of the y-axis. Oh gosh, it happened again. Sorry. from current slide. Everything that is to the left of the axis has to be on the right of the axis. So whatever I draw over here, I got to draw the same thing over here. So as best I can, I got to mirror that. Oh dear, I didn't do that very well, but something like that. So everything over here should be the same as everything over here. Now, as far as turning points go, I have 1, 2, 3 turning points. I can actually have up to 9 turning points. So if you wanted to, can I get a different color pen here, I wonder? Probably not. If you put another turning point, say in like over there, okay? And you'd have to do the same thing over here, all right? So you're gonna have to, oh gosh. How did I do that? Like, no. Like it's over here, sorry. Yeah, so whatever you do over here, you have to do over here. Okay, so you can put as many turning points as you want, but you can't have any more than 9. And so as I have here, 1, 2, 3, 4, 5, 6, 7. I have 7 now. If I wanted to put another one over here, I'd have to put another one over here to mirror it. Okay, I had to put another one over here to mirror it. But now I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now I have 11 turning points. All of a sudden this is wrong. But I can make it right by just putting a 3 there. Now I have a multiplicity of, or I have a degree of 12, right? And so I'm okay. So be careful how many turning points you put in. All right. If you wanted to just keep that as 1, then you can have no more than 9 turning points. So what would I be looking for here? I would be looking for the end behavior. Okay. I'd be looking for the zeros. I'd basically be looking at all those 5 criteria. Does your graph follow the 5 criteria? All right. And so there's more than one possible. Well, there are a limited number of correct answers for this, but there's more than one. There's like 2 or 3 correct answers here. I suppose you could go really wacky, put a whole bunch of turning points and just keep changing that to make it work, but you don't have to. Okay, now, questions about this one? All right, well then I'm going to get out of here. I'm going to keep all those, I guess, and I'm going to stop sharing. All right, the last question on the test, the rectangular container. There is a question like that on the test, but I'm going to treat it like a bonus question. Okay, I'm going to treat it like extra credit. I hate to use the words extra credit, so I always use the words bonus. So there is more than 100 possible points on this test. Okay, if you get every darn thing correct, you're going to get 104 out of 100. All right, so if you try the bonus question and allow me to give you partial credit points, then that will help you with possible mistakes that you made elsewhere. All right. I need a drink of water. I've been talking for a long time. I hope that helped. Did that help? I hope it helped. And I hope somebody's listening. So I'm going to